Everyone, thank you all for coming here this evening. It's going to be really special. You're going to be learning a couple of things about food and nutrients that you probably don't know about yet. Dan Kittredge from Massachusetts in the USA, from the Bionutrient Food Association, has come to Kenya, and we've taken him on a marathon tour. This is his 4th presentation in 2 days. So if we stumble and stutter, just bear with us, okay? It's been a long haul just over the last 24 hours. My name is Sue. I work in a company called Green Dreams Tech. I'm the CEO and the founder of iCow, which is a platform that helps to educate smallholder farmers on regenerative production systems. I want to set the scene for us about the food systems in Kenya and why what you're going to hear from Dan is so critically important for not only our country and biodiversity, but for our own health at a cellular level. In the year 2000, there was an expose on NTV done, that was 25 years ago, that talked about the soils in Kenya. And the report came up and showed that our soils were failing. That was 25 years ago. The report said that from the 80s, we had not increased our staple production of maize and wheat. We've not increased the yields per hectare in the last 20 years. Our production systems, as we all know, I'll use the word conventional, although Dan will attest to there being nothing conventional about what we actually do. But our production systems were predominantly high input, a lot of fertilizers, a lot of pesticides. That was up to the year 2000. In 2022, so that was now another 22 years later, the Heinrich Boll Foundation did a report on pesticide use in this country and showed that Kenya uses hundreds of pesticides, half of which have been banned in other places in the world, but are still being used here in our food systems. They said that it was about time we looked at all the dangers that we were seeing that this were coming across in not only plant health, but also livestock and people, and that we needed to change systems to be more regenerative in the way we attend to our soils and our food production. 2 years later, that was 2023, I think that was 2022, anyway, it was 2025. They did another report now, another soil report. So this is coming 25 years after the one that said our soils had failed, and showed that our soils were in further critical state. The jury is out to how much arable land Kenya actually has for food production. Some say 20%, some say between 11 and 12%. But what we do know is that 63% of these soils are acidic, and half of them are severely acidic. And the reason they're in this condition is because of the way we have been conducting agriculture now for 45 years. In 2025, a couple of months ago, our Cabinet Secretary, Honorable Mutahi Kagwe, banned the use of about half of the pesticides in the country, and he put an arrest on any of the glyphosate coming into the country, and has put some others on hold pending review. So something is being done, which is great news. In 2017, I did my first TED Talk, and I spoke about the people that are at the front line of agriculture, our farmers, and how they're the first users of these toxins. My worry back then was how it was going to affect them. We normally talk about how toxins affect consumers, how they affect animals, sometimes plants, but we never really talk about the people who are handling them. And a couple of months ago, there was another report that showed that in some of our high production areas, farmers were dying of cancer, long-term cancer that has happened over tens of years, but now we're seeing those results. We're also seeing in some of our highest productive areas stunting in young children, especially boys, and reproductive disorders and obesity in young women of childbearing age. I use the term chemical castration, and I don't know what other words I would use about our food systems and what we're actually doing to us humans. In my work, I started doing a deep dive into some of the problems that farmers were seeing, and it started off with cows, the very big, obvious things. It was the most expensive asset the farmers had, where they would rely on animals for production of milk on a daily basis. Many of them were having issues. The two main issues were cows losing their calves at birth or succumbing to milk fever, and mastitis. So that is an infection of the udders, and genital mastitis and chronic mastitis, where the udder no longer was as productive as it should be. The animals that we have in the country are high yielders. The production systems don't quite support that, neither does the feeding, and there have been problems. And there's a lot that's being done to try and solve that, but that's where I started my journey with farms. It was in the area of cows, hence the name of the product, iCow. And then we started looking, as we were working with farmers through feedback loops, at the next level of problems that they were having. And there was a lot of stuff in crops, different crops, fruits, different livestock. And eventually it dawned on me that the real problems were the soils, because everything depends on soils. Every cell in your body depends on healthy soils. So I started digging into soils and learning, literally digging in and learning, and I joined the Elaine Soil Food Web course, and I took her entire course right up to doing the lab tech course. So I then had a microscope and I was looking at soils under the microscope. And what really pained me was it took me so long to get there, 25 years of working in agriculture, hearing that soils were alive, believing it, but never really seeing it. And I vowed, when I saw the microscopic life in soils and I saw what dead soils look like, that I would do everything that I could possibly do to make sure that all farmers could see this. Because we're given promises, farmers are told soils are alive. But when problems come around, pests and diseases, they will go straight to an agro dealer, and an agro dealer will say, take this, spray this, do that. A lot of that impact further kills the soils, and they're in this cyclic degradation of soils, health, livestock health, and their own family health. Along the way, I started the soil advocacy course, teaching farmers on Zoom now and teaching extension service providers how to create living soils, what they needed to do, what they needed to identify, how soils actually formed. And it was through that process, as I was looking online and learning about new information, that I came across Dan's work about nutrient density and the connection between nutrients and soils. And it blew me away. And I wrote to him and I said, I want to come to your conference. Dan holds an annual conference. He's been doing it for the last 12 years. It's over 12 to 16 weeks. There's one guest speaker every week. And the stuff that you learn is absolutely mind-blowing. But it was expensive. And I said to him, I want 100 of my soil advocates to come. Can we do something? And he said, let's talk about it. And we got a reduction in price, and 100 of my students are now able to join this class and have done for 2 years. Thank you, Dan. For 2 years consecutively. That's put Africa on the map. My students now in my classes are across the African continent. And it's brought us now into the conversation about nutrients and nutrient density. And I asked Dan, I said, will you join my class? Will you help me teach? There are certain aspects of what I'm trying to do. I would love if you join. He said, when? And he jumped in and has been teaching my classes ever since. Again, thank you, Dan. It's just amazing. Just amazing. And then he said, I want to come to Africa. I want to come and meet the farmers. For 2 years we talked about it. And I was like, when? And he's traveling all around the world, doing all this fantastic education and teaching and training and trying to network and join all the individuals like me, like you, into one place so that we can all have the right conversations around food systems. And then finally this year we got into the when can you come and his flying dates, and I said, let's just put your dates, and we'll book the venues. And that's how it happened. And here he is. So on that note, I want you to all give Dan a big round of applause again. And over to you. He's going to take us through what got him here.
sure why this turned off. Is that on purpose or by mistake?
Oh no, it's because you just took the light back.
No, it happened off. Not sure when it lost the power. It feels like when it got unplugged.
Did I stop it?
I don't think it was you. Thank you very much, Sue. And you're doing wonderful work here. And it's an honor to be introduced to your community, and it's been a wonderful relationship developing. So I will start, and hopefully the tech will work. Got unplugged. There we go. Okay. So my name is Dan. You've heard that, figure that part out. You're entertaining for the evening. I think your plan is that I make a presentation, and then we break for some wonderful food, and then we have a Q&A. So I'm going to try to keep it tight in the presentation because we're starting a little bit late, and I'm sure everyone's looking forward to delicious food. So this, I'm not sure what that is, but I'll ignore it. Okay. This is the farm I grew up on. I'm from Massachusetts in the US, which is the northeast corner. People have heard of Boston. That's our capital city. My parents were community organizers in Boston when they met in the 70s. They decided that they did not want to raise their children on the streets. They wanted to raise their children in the countryside, so they bought a piece of land and built a house and started a farm. And they didn't really know how to farm, and they were community organizers. So they were actively involved in the organic farming movement. They helped establish one of the first organic farming organizations in the US in the early 80s. They helped write some of the first organic standards in the US. My mother was the executive director of the organization for 35 years. My father was the editor of the journal. They organized the annual conference. So I had one foot, on the farm, growing up on a farm, and one foot in the movement, in the food movement, in the organic farming movement. I worked on the farm through college, through my 20s, and then into the farm in the summer and traveled the world and do various activist things in the winter. When I got married at the end of my 20s, I had found no better lifestyle, I thought, than raising kids on the land with both parents at home, with as few screens as possible and as many neighbors and family members as possible. I thought that was a good way to live life. From everything I'd seen, that seemed like it was, a way to go. The only viable skill set I had was farming. And what I came to realize quite rapidly is that it wasn't that viable. Like my parents, I was unable to make a living farming. My crops regularly succumbed to infestation and disease. My mind was quite focused at that point in time because I didn't really have a backup plan. I had no other marketable skills. I had young children, I had a wife, and I'd been brought up with this orthodoxy that organic is better. We had our noses elevated at the farmers market every Saturday morning in town because we were better people, because we were organic. That's just the way it was. It was only when I started looking around, looking at nature, there's lots of beautiful nature around. I got to think about, we've got all these beautiful trees and grasses and things that grow themselves every year with no effort, and no pest pressure, and no disease pressure. And here we are, laboring long and hard in the fields, and constantly having our crops succumb. And I was wondering why it was that the plants that nature grew so well, and the plants that I grew so poorly. And finally came to the realization that maybe I was not that good of a farmer. And I recommend anybody, to engage humility. I think it's a really powerful place to come from. And so again, my mind was focused, and so I started reading books and going to conferences, attending seminars, and sort of integrating other pieces of perspective beyond the organic orthodoxy that we brought up with. There's permaculture, there's agroecology, there's biodynamics, there's biochemistry, there's microbiology. There's a number of other modes of perspective that are pertinent and relevant and have been developed by humans over time. And I would study in the winter and practice in the summer. It didn't take very long, probably 2 years all told, before I had gotten to the point where the pests were gone, the diseases were gone, my yield was up, the cost of production was down, and I was literally making my living farming, working 20 hours a week. I had time to play with the kids and take naps and you know, step into that sort of more balanced lifestyle. And I don't know what it was exactly because I've always been shy, and I've always been shy. Let's just say it. But I felt this obligation to start talking. I knew from my whole life that farmers generally can't make a living, much less working part-time. And I knew a lot of farmers who were very well-meaning who were unable to do that. And I felt like I had come to some perspective from all my years of experience, but also integrating these other dynamics that I wanted to share. And so I asked my mother, who was running the conference, if I could give a workshop at the conference. And she said, sure, there's a lot of equity workshops, we'll give you one. And from that, some farmers attended and said, hey, would you come do a half-day course for us? And then I did that, and some of the farmers said, hey, would you come do a 2-day thing for us? And, pretty soon I was giving courses to farmers all across the northeast of the US. And then at that point founded this organization called the Bionutrient Food Association, which is, this is our logo over here. This used to be the front page of our website. And that's the work I've been doing for, as a professional now, as in an educational organization, working with farmers to help them understand, I call principles of biological systems. How did nature evolve things to work? How was it that plants grew for 420 million years before God invented fertilizer? All right? Which of the first 6 days that God invented fertilizer? Anybody remember which one? I don't think it was any of the first 6 days that God invented fertilizer. There's these ways that nature has this thing working, actually are beautiful, profound, elegant, and simple. Not necessarily part of our agronomic textbooks. And so this is what the work of our organization has been. This is the other half of this work. As I was, again, learning and studying and sort of garnering perspective from elders in a broader field, I came across this instrument called refractometer. Has anybody heard of a refractometer? A Brix refractometer? I've got one here. I'll show you. It's a remarkably simple piece of kit. It's been around for about 195 years. It measures the refraction of light as it passes through a fluid. I think they cost, if I get my numbers right, about 700 shillings, brand new. You can use it 10,000 times or more until you drop it on the cement floor and break it. But there's no battery. And with this and a garlic press, you can take a leaf of a plant, squish it, get a drop of juice on this slide, look through, and you can see how healthy your plant is. There's a scale. The Brix reading will predict remarkably well if your plant is susceptible to infestation of disease, if it's likely to be growing vigorously, etc. I was like, my God, my entire life, we've been putting plants in the ground and kind of just hoping. And then the diseases would come, and then the insects would come, and they're like, yeah, well, that happened last year. We never actually had any metric for actually measuring overall system health. And that wasn't it. The other half was you can do the same thing with a piece of cucumber, or a carrot, or a potato, or tomato, or blueberry, or apple. You can take a piece of food, again, put it in that same garlic press, squish it, get a type of juice out of it, it's on the screen, you look through, and you get a number. And that'll tell you relatively how nutritious that food is. There's a variation in nutrient levels in food. Anybody ever had the experience of taking a bite out of a tomato that came off of a grocery store shelf? Anybody here ever eaten a tomato off the shelf of a grocery store and had that remarkably sort of non-flavor experience? Who here has eaten a tomato fresh off the vine and had a profound flavor experience? Do you know that you're an animal? That you evolved with sophisticated nutrient monitoring systems to tell you what is good for your children and the next generations and not? Did you know that thing we call flavor is actually a remarkably sophisticated nutrient monitoring system that connects to overall system function? I think something along the lines of 30% of our DNA is associated with the function of our nose and our tongue. There's a bunch of stuff that goes on in operating a body. 30% for our nose and the tongue? Well, if you eat food that is insufficient for your system to function, it will not function sufficiently. Right? Your children will be less than functional. Actually, this thing called flavor in food is profoundly important in our overall system function. I got brought up with the concept that we were organic, our food was better in this conversation. When I got the refractometer out and started measuring my food as an organic farmer, it was quite embarrassing. The numbers were remarkably low. They correlated with a non-optimal flavor and significant susceptibility to infestation and disease. So this was really exciting to me. I'd been brought up with this idea we were better because our food was better. And I knew people from the permaculture world who knew they were better because their food was better. I knew people from the biodynamic world who knew they were better because their food was better. There was people from the local world who knew their food was better because they were better. And now we have this thing called the regenerative. You guys heard of this regenerative thing? The new fad in the food movement, I call it. Like, everybody who's regenerative kind of knows they're better. Right? I think there's a role for science. There's a role for science in measuring things. And so part of the work of our organization has been looking at this question of the actual nutritional caliber of the food. So this was 17, 18 years ago. I was in these conferences, I was talking to these elders, I said, my God, this is amazing. This is completely exciting and pertinent and relevant. And who's talking about it? And what's the word for it? What's the word for this nutrient variation in food? Where's the ecosystem of, entities organizing, educating around this thing? And they said, well, there is no word for it. And there is no group organizing around it. And so I put my hand up and I said, let's create a term. We created this term, nutrient density. And so that's going to be the term we engage in here. And that's what, was it's the cause of inspiring the creation of this organization, the Bionutrient Food Association. This number needs to be changed. We're 15 years old now. Our mission is increasing quality in the food supply. And by quality, we're talking about flavor, aroma, nutritive value, health-giving attribute, which we think correlates with soil health, ecosystem function, carbon sequestration, farm viability, a whole bunch of other concomitant benefits. Specifically, when we talk about increasing quality in the food supply, we mean we want the ambient level of nutrients in food for all humans on the planet next year to be higher than it is this year, and 2 years from now to be higher than it is next year. We want to facilitate the increase in nutritive value in food for everyone, everywhere. That's our mission. We started off, as I said, doing workshops, education, courses, conferences. Here's some of the people who've spoken at our conference over the many years. If anyone here knows any farmers, all the recordings, every presentation at any one of our conferences has been recorded and is live and freely available on YouTube. Our thought is we use our privilege to facilitate as much education and empowerment for as many growers globally as possible, full stop. So that's that. As the workshops evolved, I went from one farm to another. Farmers would say, hey, this seems to be working. And they tell a friend of theirs, I teach a course over here, and we found their field, and further afield. And pretty soon, it was no longer North America, it was other continents we were teaching these courses in. And it didn't matter what the scale was, it didn't matter what the soil type was, it didn't matter what the crop was. These basic principles of working with life seem to be applicable. If you support nature in what she needs, things work more well. That basically seemed to be what was happening. And our thought was, if that's true, if helping people work with nature heals the environment, improves farm viability, improves human health, this is the kind of thing that we want to bring to scale, right? Like, we could solve a number of apparently intransigent existential issues if we were to bring this into scale. So that became our effort, our vision. So the next question was, how? How do we bring this to scale? And our thought was we would align economics with these other aspects. Is there a way to align economic incentive with ecological incentive and human health incentive? Can we make it economically advantageous for people to facilitate this outcome? Because our thought was money is a very powerful force in today's day and age. You ever heard of this concept? Money is a powerful thing. People make decisions based on money, not the greater good sometimes, because money actually drives survival. Maslow's hierarchy of needs. I'm guessing a few people are familiar with this concept. So that was our basic question. Is there some way we can align economic incentive with these overall systemic benefits? And our vision was that if we could provide people who buy food for their families the ability to discern from the choices available to them which ones are better and which ones are worse. If you have 3 bags of apples available to you, and you could know one was 20 out of 100, one was 40 out of 100, and one was 80 out of 100, all other things being equal, we presume you'd likely choose the 80 and leave the 20 on the shelf. Anybody here disagree with that? People here spend money on food for their family. Yeah? You generally want the best for your family. So if you could choose the food that's more nutritious, you would. You guys are kind of flat audience here. So few. Occasional nod would be good if you don't mind. Or we'll wait a little while. Yes. That was the vision. We have this thing called a refractometer, which you can actually get assessments off of food with, but you have to take a chunk out of the apple and squish it to get it out of juice before you can get a reading, before you can get a number. And generally, what's that?
Try that out.
We can try that out. We can do that after the break, absolutely. What's that? Beef it up. Really. It is quite, the penny does drop when you take a food that you think is good, and you see the chart, and you squish it, and you get the reading, and you're like, oh, let's try that one over there. Let's try that one over there. Oh my God. So, well, yes, absolutely. So the vision is there some way we could have something like this that you could use to measure food, but non-invasively? That you could actually measure with a flash of light. Has anybody heard of the Hubble Space Telescope? How about the James Webb? These big things that cost lots of money, they're up in space, and they do something with stars, take pictures and stuff. Heard about them? Right? Apparently, if you ask an astrophysicist we'll just use Alpha Centauri as an example, because Alpha Centauri is only like 8 light years away, which is pretty close. 8 light years, right? It's a lot closer than most things. It's the closest star to us, not the sun. If you ask an astrophysicist, what is Alpha Centauri made up of? Not that you would, but if you did, they would tell you with great confidence, Alpha Centauri is 51% hydrogen, it's 48% helium, it's 1% other gases, and it's those ratios. We know exactly what it's made up of. We've never sent a probe past the edge of the solar system, which is about 18 light hours away. The farthest thing we've sent, like the physical thing we've sent out, is 18 light hours away. Alpha Centauri is 8 light years away, and yet we know exactly what it's made up of. How? Through a science called spectroscopy. Spectroscopy says that what you call copper in chemistry is a certain vibration of light, a certain color in physics. What you call zinc in chemistry is a certain vibration of light, a certain color in physics. Phosphorus vibrates, potassium vibrates, polyphenols vibrate, protein vibrates. All these things we call compounds in chemistry or nutrients in chemistry are vibrations in physics. And if you take the picture of the right frequency of light, you can actually see what the thing is. Not by going there and taking a sample and bringing it to the lab, but literally by taking a picture of this vibration. So our thought was, could we have a handheld consumer-priced flash of light nutrient meter that could be in people's hands that could help them choose what's better and leave on the shelf what's worse? That was the vision. So we started this project in 2017. Most people we talked to said, this is Star Trek. This can't happen. This is impossible, right? A handheld ray gun, this is what it is? No. But then again, that was only 10 years after smartphones had come out. Anybody remember before smartphones came out? Like if anybody told you 25 years ago that you could have a thing in your hand that did 850 different things, you'd say, bull. But now, 3-year-olds are like completely competent and presume this. Yeah? Yeah. So our thought is, like, is it possible if we could take a picture of something light years away and figure out what it is, that we we can take a picture of something a millimeter away and see what it is. So to verify or prove principle, we asked 3 questions. How dramatic is nutrient variation in food? What causes it? And is it possible to build meters to test it? So we started this work the first year, 2017, we built our first meter. 2018, we built our first lab. We had people send in carrots and spinach from across the US, from grocery stores, from farmers markets. We wanted to see what was the spectrum of variation of nutrients in these labs. So people just literally sent in samples from across the US. 2019, we set up our second lab in Chico State, California. That year, we went to 6 crops. We had people send in the soil the crops grew in terms of questions like what was the variety, what was the soil type, what was the fertility program, where did you purchase it, was there any labels on it. The third year, 2020, we set up our third lab in Europe, in France. You can see here, each one of these green icons is a farmer sending in samples with the soil, with the management data. The orange icons are citizen scientists sending in samples from grocery stores, farmers markets, farm stands. These are the nutrients we looked at in the food. These are the metrics we assessed in the soil. Over here, we have all the different crops we assessed that year and the numbers of them. 3,800 samples of crop that year, about 10,000 samples of crop altogether over the multi-year process. Again, this is our preliminary work, working to try to identify the answers to these first 3 questions. So I'm going to show you a couple slides about what we found, just to give some context here to this conversation. What's that?
How many years is the sample that you just showed?
That was just 2020.
With 1 year.
This is the data from 2020. We started in 2018, and we did 2019, and we did 2021 as well. So there's 4 years of data from 2 continents, 25 crops, 10,000 crop samples, 8,000 soil samples, a decently large data set, if anybody's a scientist. Okay, so I'm going to go over here. Here, so all these graphs I'm going to show you are of carrots. We have graphs like this from 20 other crops as well. They're all on our website, bionutrientinstitute.org, and we'll review them. And I can tell you that these graphs, they look remarkably similar, regardless of what crop it is. This first work was only with roots, leaves, fruits, and grains. So, oats and wheat and blueberries and tomatoes and apples and pears and Swiss chard and kale and spinach and leeks and potatoes and beets and carrots. Roots, leaves, fruits, and grains. These graphs that I explained to you, understand this is what we found across 2 continents and across 4 years, remarkably similar. So this is just nutrients, and the nutrients we looked at were nutrients that we understand to be deficient in people who consume whatever a modern Western diet is. So sulfur is one of those nutrients. The lowest we found was 8.41. This is in milligrams per 100 grams of fresh weight. The highest we found was 33.19. So anybody who understands numbers? This one has 4 times as much sulfur as that one. So if you wanted to get sulfur out of a carrot, if you take 4 of these to get as much as if you have 1 of these. 4 to 1. That's a decent sized variation. If this is 0, this is 100, and that's 20, 40, 60, 80. So these colors are basically there to help you break up. It's called the fifths of the range. This is a bell curve. This is the natural distribution. This looks like a real thing. We have enough samples here. What we see is the peak of the curve is in the 23rd percentile. Here's the 50th percentile, right? That's 40, that's 60, this is 50. There's way more samples below the 50th percentile than above the 50th percentile. Right, relatively speaking, most carrots are low in relation to what they could have in sulfur. Here's phosphorus, 11.7, 93.69. That's 8 to 1. It's an 8 to 1 variation. So this carrot has, if you eat 8 of these to get much phosphorus, if you get 1 of those, peak of the curve in the 27th percentile. I like to say, anybody here go to university? How many went to university? Anybody? get grades at university. And when I went to university, we had this thing called grades. At the end of the semester, they'd average up your final exam, your midterm exam, your papers, any other things you had, and they give you a number. And everything between 90 and 100 was an A of some sort, and 80 to 89 was a B, and 70 to 79 was a C, and 60 to 69 was a D. Everything below 60 was an F for failure. No credit was given. Yes? People know about this? So we'll talk about if you ever got an F or not. You don't have F's in South Africa? No. Q's or P's or what?
Pass rate is 30%.
Pass rate is 30%. I did take organic chemistry, and somehow I passed with about a 30. But that was called grading on the curve. That was the only class I ever got graded on the curve, was organic chemistry. If that's the range, if that's how we're envisioning this, we can understand that this section here is the 90s, here's the 80s, here's the 70s, here's the 60s, right? A, B, C, D, and here's the Fs. This is what we're seeing is the vast majority of the supply chain is remarkably low in relationship to what it could be. And if we're growing food for nutrition, as opposed to for volume and aesthetic, we're failing. At least in North America and Europe. I can't speak about Africa because we haven't actually sampled anything from Africa yet. Here we are with antioxidants. People heard about antioxidants? You've heard about them?
Yeah.
They're getting to be more of like a thing people talk about. Generally, they're understood to be good. 4.92, 195. That's a 40 to 1 variation. You have to eat 40 of these to get as much as if you make one of those. That's a lot. Peak of the curve in the 13th percentile. Again, similar range. Polyphenols, here are the things we call flavor and aroma. Remember the point about sophisticated nutrient monitoring systems? These compounds that we call flavor and aroma, as humans, scientists call polyphenols and terpenoids and alkaloids. They got fancy names for them. Those are the things in the olden days people called medicinal. So remember like 200 years ago or 500 years ago, there was this concept of medicinal plants, that bioactives. You have like herbs and spices that you would take if you have an imbalance or disease. Like the medical practitioners would say, you got this disease, take this nutrient, take this food. What we understand now with 21st century science is these compounds are highly functional at reversing chronic disease. Things like cancer and diabetes and heart disease and cancer, etc. These chronic diseases, the proteins that are associated with them are rapidly disassembled when you have these compounds in your blood. 2.34, 49.75, that's a 20 to 1 variation. Peak of the curve in the 7th percentile. Right? The answer to the first question, how dramatic is nutrient variation, is big. Nutrient variation is big. There's a lot of nutrient variation in food. 4 to 1, 8 to 1, 40 to 1, 20 to 1. This is not small. And this is the nature of the supply chain from everything we were able to assess over multiple years of multiple continents. Like I said, 10,000 samples. Second question is what causes variation? Here we have a variety. People think that genetics is a big deal. A lot of the scientists tell us that genetics are a cause of nutrient variation in food, if there is a nutrient variation, which in most cases probably there isn't. That was a story we heard from the university people here, well, not here, but in the US. Those people at the land-grant universities are like, nutrient variation probably isn't that big. But if it exists, it's probably genetics or environment or some management technique. Okay, so here's genetics. And these are measured not by individual nutrients, but by a thing called BQI. BQI is a stand-in for quality. It's a bionutrient quotient index. Basically, it's 6 elements of 2 compounds averaged together. We're not saying it's good and bad. We're just saying, based on the nutrients we looked at, let's average them together and see what we find. Napoli is a variety of carrots. Bolero, Naples, Mocha, Romance. These are all varieties of carrot. Some Napolis are in the red, a couple in the light green. Boleros, Portuguese, reds, some yellows. Naples, reds, light greens. Mocha, red, dark green. Romance, red, light green. What we see here is not that if you plant this variety of carrot, you'll get this level of nutrient, but this variety of carrot planted here will have a low level of nutrients, and this variety of carrot planted there will have a high level of nutrients. Not seeing any significant correlation here between genetics and nutrient levels. Again, we've got data like this for 20 other crops, and the graphs are remarkably similar, and you can find them on our website. Just pull carrots out because we had a few more carrot samples than the samples. Climate region over there. Some people say it's the soil type or the climate dynamics that correlate with the nutritional value of your food. Well, we can't grow good potatoes here because of the soil type. Okay. So the U.S., covers a lot of North America. What we have here are climate regions in the U.S., the Northeast, East, North, Central, Southeast, Central, Northwest, West, Southwest. Different parts of the continental U.S. Some are hot and dry, some are hot and wet, some are cold and dry, some are cold and wet, some are sandy, some are clayey. We have different soil types, different climate dynamics. And we're not really seeing, again, any meaningful connection between if you grow here, they're all good, or if you grow there, they're all bad. I'm from the Northeast. That's where we started our organization. That's where we had a bunch of small, organic, no-till, permaculture, regenerative farmers who knew they were better. That's where all these samples come from. That's why there's a whole bunch over here. That was our core base of, allies. Out of 115 samples, we have 2 in the top 20%. A lot of reds, a bunch of oranges. East North Central, a bunch of reds, a bunch of oranges, a green one. No meaningful connection I'm seeing here between soil type and climate zone and nutrient levels. That means you can do a good job anywhere, and most people are doing a bad job everywhere. Okay, point of purchase. Here's the farm, fresh and local farmer. Here's the store, those big bad grocery stores. Here's the garden. All people growing in gardens are great people. And here's the farmer's market. I'm not seeing any meaningful variation between them. Some farmers are doing a good job, not many. You can find some really good samples in the grocery store, but not a lot. Gardeners may be good people, but they're doing a great job growing food. If nutrition is your objective. In the farmer's market, while we may love talking to our local farmer, does not connect necessarily, or actually in any meaningful way, to improved nutritional levels of food. This is uncomfortable for a lot of people in the food movement, but that's what science is for. Science is for collecting data and finding patterns and being humble and non-dogmatic, letting go of your egos and your dramas and your religions and saying, this seems to be a pattern, let's see if we can learn from it. Let's see if there's opportunities to grow and improve. This was the worst one for anybody who's in the food movement, last one. Certified organic. There's 2 out of 131, top 20% now. People use cover crops, one of the key things the regenerative movement is all excited about. 1 in the top 20% now. No-till, another one of the regenerative things. If you just no-till, your things will be better. Well, there's 3 in the top 20% out of 84, but that's only 3 out of 84. I'm not worried. There's till, 77 samples. I mean, it's a little bit worse, but really not too much. Organic, not certified. This is small farmers who don't get certified, but practice organic practices. Okay, I guess it's a little bit better than till, but still. These are called violin graphs. Violin graph is where it's fattest, is where the preponderance of the samples are. And you can see this, like, certified organic is fat is definitely in the orange. Cover crops, okay, it's a little bit in the yellow. No till, pretty much still also in the yellow. Till actually doesn't look like it's kind of in both, yeah? Organic, kind of in both. Reference and none. Reference and none, that's grocery store, not organic. That's the bad stuff, right? Those are the bad people. Where's the fat? In the yellow. It's not really fat in the orange. You can't really tell me that's fat in the orange. What does that mean? That means that some farmers that are big farmers aren't bad farmers. Actually, if you average it all out, they're kind of a little bit better than the ones above. Remember, I grew up on an organic farm. My parents ran an organic farming organization. They wrote some of the first organic standards in the US. We sold every Saturday morning at our local farmers market. The religion I was brought up with said this is not true. But I also went to university, and I did study science, and I do like the concept of data collection and being dispassionate and impartial and getting our egos out of the way. And for better or for worse, this is what the data seems to tell us. Here's regenerative. This is the new ism of the decade. Regenerative, definitely not fat in the yellow. If we're just looking for rough pattern, that's all we can do here. This is preliminary data. This is, we're looking for patterns. Biodynamic. Here's local. Actually, local is fatter over here, farther than anybody else. So we can say that, but let's look at you got some red ones, only one dark green one. So the basic point here is none of these differentiating factors that people identify with seems to be predictive in the nutritional caliber of food. Not that that's why people buy food, but if it is one of the things you're concerned about, don't make the mistake of telling yourself that just because something's organic means it's more nutritious, or because it came from your local farmer's market, it's more nutritious. So the only thing, after all this science, after all these data points, the only thing that we found that seemed to correlate with improved nutrient levels in food was the level of life in the soil. Only when the microbiome was functioning more well did we have a pattern that said increased levels of nutrients in food. And when the microbiome was functioning less well, lower levels of nutrients in food. Which, if anybody knows about evolutionary biology, makes sense because it was the microbes that evolved plants. And microbes are the gut flora of plants, at least that's how plants evolved. And when your gut flora is in bad shape, you know about this? When your gut flora is in bad shape, that you're not doing well? There's a connection between your health and your gut flora? Yes? That's what we seem to find with plants too. The more well-functioning the gut flora of the plant was, the better the nutrient levels it got. So, okay, can we say a level of life in the soil is kind of like soil health? Soil health connects to nutritional levels of food. That's maybe a hypothesis we can end this thing with. Nutrient level variations are massive, and soil health connects to nutrient levels more than soil type or genetics or certification or point of purchase. That's what we seem to be finding. Okay, the third question was, can you build a handheld meter that tests nutrient levels in food? And I have one of these here. Again, if you go to our website, you'll see this. We got published in a journal called Nature Scientific Reports, which is a well-respected, credentialed, peer-reviewed journal, that this little handheld piece of kit, which is a 3D printed case with a cheap little chip inside that we engineered and manufactured in China for $100. It's got 20 LEDs and 10 LEDs in here. Sorry, 10 LEDs, light emitting diodes. Was able to, if you pointed it at a carrot, if you put a carrot on it, and you with the smartphone push the button, it'll flash the lights, the little LEDs at the carrot, take a picture, light bouncing back, and spit out a reading. We can predict levels of antioxidants in carrots with a flash of light. We can predict levels of polyphenols in zucchini with a flash of light. Protein in wheat and oats with a flash of light. it is possible with a flash of light in a consumer-priced handheld meter to assess nutrient levels in food. So our first 3 questions en route to this grand vision have been answered in the affirmative. It is possible to build handheld consumer-priced flash of light meters that can test nutrients. Nutrient variation is dramatic. That nutrient variation connects to soil health. So this whole thesis of a way we could have the world be a better place, which is by giving people who buy food for their families the ability to choose which food to buy based on nutrient levels, and in so doing, have improvements in the health of their children and the health of the ecosystem. That is a viable vision. We've checked this out in the scientific method, and we've had reason to believe this is a path that is possible. And this is 2021. This is a couple years ago. So preliminary work complete. Now we start the real work. How would you presume to say this carrot is better or that carrot's worse? Because I've talked to a lot of people about this over the years now. They're ballparking 10 million different compounds in food. You might have heard about copper and zinc and vitamin E and vitamin D and vitamin C. You might be able to list 15 or 20 nutrients. The scientists who are doing the deep assessment of all the things that are in food are ballparking it at about 10 million. So we're not talking about vitamin D or copper. We're talking about carrot. How do you say from the overall complexity of biochemical aspects of a carrot, this one is 20 out of 100, this one's 80 out of 100? That's a complex science project. This is what we've been working on for the past few years. We started with beef. Beef, is the foodstuff that is produced on more acres of land than anything else. But we're not saying about the climate and the land and farming, and if farming was better, maybe the climate would be better. So we thought we'd focus on the thing that had the biggest ecological impact, and that was cows. Our hypothesis was that if cows eat a diverse polyculture of plants, which is what cows have evolved to eat over millennia, they would be healthier, the ecosystem would be healthier, and the people who ate them or drank their milk would be healthier than if they ate a bunch of grain, which, at least in the US, is what the vast majority of cows eat at the end of their life before you get to eat the meat that goes to their body. Right? So we're proposing that there's going to be a connection between the nutrient levels in the meat and the fodder the animals consumed. This is our hypothesis. Our PI, our primary investigator, is Stefan Van Vliet from Utah State University. Experimental design here. We had farmers send in triplicate samples, so you send in a steak and 3 animals. We started with 800 different nutrients in the steak. We got down to about 150. We realized we didn't really test 150 probably was enough. Different nutrients, elements, enzymes, vitamins, fatty acids, polyphenols, terpenoids, alkaloids, all kinds of different types of nutrients. We looked at the manure, and we looked at microbiome. We looked at hundreds of different species of microbes in the manure, different kingdoms. If we want to do a really complex microbiome assessment, we looked at the feed or the forage. We had the farmers send in what they were eating before they were killed, so we could assess that. We had them sample the soil, take the soil that their food grew in, and send that in, so we could assess that. We asked them a whole bunch of management questions about how they were raised, their age, their gender, their breed, how they were moved, etc. And then finally, we did human health trials. So we said to people, you guys eat this grass-fed beef, and we'll watch what happens to your body and see if it looks like it's beneficial or detrimental. And you guys eat this grain-fed beef, we'll see what happens to your body. And you guys over here, actually everybody ate it all. First they ate one, and then they ate the next, and they ate the third. The third was the fake meat. You ever heard of this thing called the Impossible Burger? Impossible Burger? In the US, if you get a pound of mince that's grass-fed, 100% grass-fed, or grain-finished, or Impossible Burger, they all have on the back of the label the exact same nutrients. According to the US government, they are exactly uniform. Our question was, if you feed these 2 people, what happens? Because what we understand when we look more deeply is there's a whole bunch of different things in them. maybe the 8 nutrients on the back of the package are relatively uniform. But actually there's a whole bunch of other stuff in there that we thought might have a significant impact on human health. So we did all this assessment. This took many years, raising the money, finding the farmers, multiple continents, getting the samples sent in, building the calibrations, building the databases, doing the statistics. We're now on the final stage of this, which is writing up the papers. We hope that by the second quarter of next year, we will have these papers published in significantly peer-reviewed journals where we actually have found these 8 nutrients we can say are the definition of 20 out of 100 in beef, 40 out of 100, 80 out of 100. So that's our vision and our model, is we can do this with other crops. Once we do the science and we say, these are the nutrients that correlate with relatively good and relatively bad, we can publish that. And then people who want to make money with companies can calibrate meters for people to use. It looks like, at the end of the day, the camera in your phone can do this. Huawei, the Chinese phone company, has already put a spectrometer in some of their phones. So we're talking 2030, a few years out, after a bunch of research is still done, you are literally able to open your phone, open the app, go to your point of purchase, flash a light, and get a reading in real time, all the nutrients in the food. This is what seems to be entirely plausible and what we as an organization are working on. So and Sarah, where's Sarah? Where are you? There. Sarah's the development director for the BFA. We are on tour. This is our 5th continent in 2 months. The little handout you guys got was the document that we've been sharing around. The vision here is that we can do this collaboratively and collectively globally. We can develop a definition of quality in potatoes for the planet. We can develop one for rice for the planet, for beans for the planet. Let's do it systemically, let's do it openly, let's do it empirically. And so, because we're a fairly small NGO, we think, somebody could ask, who are we to do it? And so our thought was, let's go out and engage people from around the world who are thoughtful, who do have perspective, who do have context, who come from different dynamics, to listen to us, to hear the story, to consider and review the plan, and offer feedback and suggestions. So we're calling this a listening session, and the idea is not for you to listen to me, but for us to listen to you. For us to say, here's our vision, here's our plan, here's what we are working on. What do you think? So the handout is there for you to read. I do want to take a break so we can have some delicious snacks. I'm not sure what they're called. Food. Food of some sort. I don't think it's going to be a full sit-down dinner. Yeah. Okay. And then I want to have a Q&A process where we engage. I will say everything we've got on this treaty, we're calling it a treaty. The concept is with the treaty, someone proposes a treaty, and then all of the signatories negotiate it before they sign it. Like you say, I don't like this, change that, or I'm not going to sign it. So we're considering the civil society. We're talking to nutritionists and agronomists and corporates and all kinds of players, chefs in the ecosystem, and saying, give us your feedback. Tell us what you think. So I've got a few more slides on beef. If you want, I can go into them. I think I've covered the basic points here. It does look like with beef that.
Do go into them.
You ready to go into it?
Cool, yeah.
All right. I'll just do a couple more slides. I'm sensitive to time, but we'll just do this quickly. Okay. So location of farms. There's actually a couple more in Australia, and they work from right there. But the rest of them are pretty well geolocated. Like I said, 4 continents, obviously the vast majority of America, a full breadth of ecosystems and genetics in this data set. Our plan with this treaty going forward is that we have equal numbers of samples from all 6 continents where humans are farming. So when we do potatoes, we're going to have as many potatoes from Africa as we have from Australia, as we have from Asia, as we have from Europe. So every one of these 20 crops, we want to be assessing equally from all continents, quantities, different genetics, different soil types, different fertility programs. We really want to design a study where we can be sampling the planet systemically, so we can produce at least a preliminary definition that is based on good sense. The omega-6-3 ratio is something that some people have heard about, correlating to inflammation markers. Inflammation markers correlate to chronic disease, i.e., the less inflammation, the better. Lots of inflammation correlates with higher levels of chronic disease. If you take the cows that eat only grass, and the omega-6-3 ratio here averages at 1.7 to 1. The cows that finished on grain averaged at 7.8 to 1. You can see most of these cows were like highly clustered. We had a few samples that were not, and actually when we looked back and said what's going on here, it came from sources like grocery stores where claims of grass fed were made. Do you know about cows? Like, it's hard to find a cow that never ate any grass. So you could pretty much technically say that all beef is grass fed, even if they ate a whole bunch of grain too. It's like saying, has anybody ever here eaten nutmeg? Anybody here ever had nutmeg? So because you've had nutmeg, you could say you are nutmeg fed? Yes, I have been fed nutmeg. It's not the only thing I've ever eaten, but I have been nutmeg fed. So legally you can say this beef was grass fed, even though it actually was not 100% grass finished. So what we can do with this biochemistry assessment is you can look and we can say, these do not look like these, they look more like those. So at any rate, there is significant variation in the supply chain depending on what the animals eat. Yeah, so this is a preliminary marker until we have the peer-reviewed published journal, which is the definition of nutrients with the 8 biomarkers, which is really much more sophisticated, which I said won't be out for 6 months. We can look at this omega-3/6 ratio as a preliminary marker that seems to correlate with what a lot of people understand is better or worse. And diversity, plant diversity seems to be the thing that correlates most well. Everything we looked at, the number of different species that cow has access to plants to eat correlates with the health beneficial compounds in the meat that you eat. So, yeah, that's basically it. There's one more slide here which says if you want to give us money, we would really appreciate it. But, that's not flat here today. What I'm here today is to get your insight and commentary on this treaty. So, I'm ready for a break. And I'm really looking forward to engagement. So, thank you. You want to say anything, Chef, about the food?
No, I mean, this is incredible, right? We as chefs, we are always seeking flavor, right? And in ingredients, you find sugars and proteins, and we as chefs, we're trying to caramelize and seek for things to sear and add reactions. And what you're saying is incredibly interesting because if we are able as chefs to measure the amount of nutrients that you have, then you think about flavors, right? How to architect that in your palate, like what flavor comes first. And of course, the good health surroundings. So what we present today is more about dishes that are vegetable related. And all of this is grown in our farms. And we punch it with a little bit of sauces and spices and nuts and crunchiness. And the first one that you're going to eat is purple and yellow cauliflower. And it has a bunch of, as I call it, like Villa Blanca flower that we grow just in the garden. And yeah, that's kind of Cultiva food. It's a bunch of flavors and based here. And hope you enjoy.
Thank you. Yum, yum. Thank you. Principles.
Well, thank you. I mean, it's out of curiosity. To maybe, I was wondering if you went back to the outliers, the ones that have this quantity of life in their soil and diversity too, and understand what's behind it, and if it confirm the practices and the principles you knew, or did they bring in even more?
Yeah, and I had someone ask me the question earlier today about the different soil types or specific farms. We had one example, which is pertinent to this, of a farm in Michigan that had sent in carrot samples through the year. Same farm, same field, through the spring plantings, the summer plantings, and their fall plantings. I don't remember which season it was. They had a very good spring from a weather pattern perspective, and a very hot and dry summer. And they had some of the most exceptional carrots that we found were from this farm in their spring crop. And their fall and their summer crop was really quite mediocre. So they were applying similar practices. It was the same soil type, same crop, genetics. What we found was because the environmental conditions changed, like there wasn't enough moisture coming down, and they didn't have an irrigation system. The lack of moisture was sufficient to shut down the microbiology and cause the nutrient levels to decrease dramatically. So I think an extremely important point here for farmers to understand is you can't do a rote by the book protocol. I'm going to follow organic certified protocols. I'm going to follow regenerative protocols. You have to be sensitive to the fact that your soil is a living ecosystem. And if you don't attend to what it needs today, different from what it needed last week, you're going to have a soil which is suffering. So I like to use the metaphor of children. I'm not sure if anybody here has children. I'm guessing a few people do have children. If you've got people, yes, there's someone who classifies childhood. If you've got a 2-year-old, maybe you're a 1-year-old, ever had a little kid who's just crying? Anybody? I'm not sure. Children that cried. You have. Okay. One person here has had children that cried. I've had children that cry. My experience is sometimes that child cries because they're tired and they need a nap. Sometimes that child cries because they're hungry and they need to be fed. Sometimes that child cries because they ate a bunch of sugar and they went on a sugar high and they just crashed. Sometimes that child cried because they got scared. It was a loud noise or somebody was aggressive and they're crying because they're afraid. If you aren't sensitive to what the cause was for that stress in the baby, in the child, you can't properly address it. Right? Reprimanding a tired child for crying is not going to help. Giving that child a nap is what's going to help. Reprimanding a hungry child for crying is not going to help. Giving that child food is going to help. A child that's scared needs to be held. So it's similar, in my mind, like that with the soil and with our plants. Only when we're present with this soil is thirsty, this soil is hungry, this soil needs air to breathe. Only when we're present and we can actually be managing to ensure a full spectrum of the environmental conditions necessary for life to occur and flourish should we expect it to succeed. So yes, we did look, and it does seem that these basic biological principles of keeping an environment where all the things that life needs to succeed are present does correlate more than a religious thou shalt not till or thou shalt use cover crops mentality. Who wants to run the microphone back and forth? Does anybody want to volunteer for that?
Yes, sir.
There's a couple people over here. It's probably not checking.
Can you hear me?
Yeah.
So, I mean, if I understand what you just said, and I think about those charts that you had on the graph, right? With various organic, biodynamic, regenerative, blah blah blah, all these different types of farmers.
Yeah.
Where you're basically saying that so much of problem, in quotation marks, is just because people are being formulaic in terms of how they're doing things and not listening and understanding what's wrong with the baby, or is there a lot more to it, or is it too early to tell? I mean, where are we in the process of understanding this?
Yeah, I think formulaic would be a good word for it. I mean, I grew up on a farm, and no one ever taught me that it was the microbes that were how the plant evolved to eat. It never crossed my mind that the primary responsibility as a farmer was to optimize the vitality of the microbiome in the soil. I thought I was raising potatoes over here, and cucumbers over there, and tomatoes over in the corner. I didn't realize that everywhere the primary responsibility was ensuring vitality in soil life. And it didn't really matter what plant I was growing if the soil life was functioning well, because that dynamic has been going on for millions of years, and nature would take care of it. That mentality, that it's not about the crop you're growing, it's about the bottom of the food chain, which is microbiome, I think is something that farmers have not been presented with. I think farmers have been primarily presented with protocols and solutions that are connected to things that people want to sell them. I think a lot of the education that farmers get comes from one way or another, if you track it all back, with a vested interest in selling products, whether it's machinery or fertility or chemistry or infrastructure. In a lot of cases, there's people who have a business mind who are trying to harvest money from farmers, and we haven't been trained about the way plants have evolved to grow. So yeah, I don't think it's that difficult. It's really quite simple. In fact, my understanding is indigenous cultures globally had this thing pretty well dialed in, with no wheel and plow and beast of burden. And they were optimizing ecosystem function on continent scale. And it was not what we were taught. That's not what I was taught. I was taught that they're primitive hunter-gatherers. But then I also have had access to the original historical literature, where the first white man came with books and papers and pens and wrote down how tall the natives were, and how big the trees were, and how many fish were in the rivers, and how much game was in the fields. And if you read that literature of what was going on, it wasn't just primitive people randomly walking around hunting and gathering. It seems like they were actually very proactively and systemically managing ecosystems at continent scale. So I think the opportunity here is to remember what our forebears knew. I think we can use science and technology to get back there rapidly. But I don't think they necessarily knew it in the scientific way we understand it. They had stories and myth that conveyed those insights that have been learned through generations. But yeah, I think it's an issue of farmers not actually understanding what they're doing and what the root of success looks like, because it's not in the economic advantage of anybody selling things, if I can presume to contribute cause.
If I can ask one more thing. Yeah. Well, first of all, just to say, I have no experience or knowledge of agriculture or anything like that. So
Yeah.
It may be a basic question, but one thing that we've been told is that the Green Revolution, what is it called?
Green Revolution, yes.
Of how modern agriculture would just increase yields so much and blah blah blah. And that's what's creating the abundance of food produced with these heavy inputs into the system. But if you then, and maybe we don't have a choice, right? But if you go down the route of scaling back those inputs and doing it the way you're saying, is there an understanding of what that would do to the productivity and just output in general?
Yeah, well, this is, there's all kinds of data around the world from this. I can speak my personal experience as a farmer. When your plants are healthy, they're able to realize more of their inherent genetic potential. And so my experience as a farmer was, the better the soil health I had on my farm, the better my yield. My cost of inputs decreased because actually nature has evolved to cycle things, and once the basic ingredients are present, you don't need to add much. And the better the health is of the plant, the more it is able to realize its full potential. I use maybe tomatoes as an example. I think the average tomato in the US right now is between 5 and 15 pounds of fruit per plant. The world record for tomatoes is 320 pounds per plant. So that's 20x what the top of the average is for what's produced right now. So we have examples with corn. You know, the yield potential of corn is 1,200 bushels per acre. The world record is 400 bushels per acre. We're not realizing the genetic potential of our plants. So yeah, I mean, there's that thing which is strict volume, and there's the other thing which is nutrition. So the question is, do we need to eat so many calories or so many nutrients? And if you've got a 5x or 10x increase in nutrients in your food, is it reasonable to think you maybe need only 3/4 or half as much food to eat? Right? We've been measuring food by volume, not by foodness. And there's a lot of empty calories. There's a lot of issues with overfed and undernourished, right? A lot of people are obese because their bodies are telling them, I'm still hungry, even though they've eaten 4,000 calories, because the calories they're consuming don't have the critical nutrients their bodies need to function. We need much more than just calories. We need a full, complex suite of nutrients for our systems to function. And that's what's not present in our food right now. So it sure looks like we do not need to sacrifice yield for soil health and nutrition. Is the short answer. Yeah. Who's carrying my? I guess if you use the mic last, you have to distribute it to the next person.
I just wanted to say that after I learned about Dan's work, I thought, well, what's going on around me? What's going on in this area, in the Karanagata area, around some of the foods that we buy? And I tested spinach, skuma, which is kales, and onagu from those three products from 4 different stores. And I'll mention them: from Carrefour, Karen Provision Stores, Quickmart, and then from the Mama Mboga, which just sells it on the roadside. And I bricked them all. I had somebody pick up the samples on the same day, same time, brought them home and bricked them. And again, saw a massive nutrient variation, or bricks variation, across all of them. And interestingly enough, I took photographs of them and I use them in my training, and I asked my students, if you just saw this photograph, which would you choose? Because when we go and buy, we buy with our eyes, we buy with our senses, the aesthetics. And they were looking at, you know, the bigger plants, the bigger leaves, the greener leaves, the bigger stems, the more stems. And I overlaid the price and the weight. And then some people changed their mind and said, oh, they wanted to get more, you know, bang for their buck, so they were going to go for the heavier as opposed to what they thought before. And this went on and on. And then I overlaid the bricks on it, and they were just stumped. Carrefour had the lowest bricks in the vegetables that I bricked that day. It doesn't mean that they have the lowest bricks every day, but that day they had the lowest bricks. And Mama Mboga had the highest bricks. Karen Provision Stores had fairly low bricks as well. But most of them, apart from Mama Mboga, the bricks levels were below what a plant requires in order to manage itself and prevent pests and diseases, which is bricks of 12. There are only 2 products above the bricks of 12. And they say that when a plant is above the bricks of 12, when you bricks the leaves, then the plant can defend itself from pests and diseases. Most of the products are below those. Now, when we look at some of the work that Thomas Dixter's stuff, he says that, you know, different insects will eat different plants at different times or different bricks levels based on their mouth parts. And the aphid, as an example, can't get into a very strong cell wall. So the lowest bricks, you're going to get aphid infestations. And at the highest end of the bricks, before the plant can defend itself, you're going to get things like locusts. They've got chewy mouth parts, and they're stronger, and they can get in and the plant can defend itself. all of the products, apart from 2, were below those levels. So essentially, we're eating insect food. We're eating food that is nutritionally fit for insects. And if we're doing that, and we're feeding that to our children, how do we expect ourselves to perform optimally, to be healthy, etc.? So, just coming back to the questions around, from my perspective and from a farming perspective and from farmers, like you said, most farmers are not taught about the soil microbiome and how important it is for nutrient cycling in the plants, and mineral cycling, etc. And most farmers end up using a lot of pesticides and things. So even when you're looking at a low bricks product in the store, even if you have the choice of buying it, the chances are it's full of pesticide if it looks clean, because it's been sprayed.
Yeah, I think it's one of those things. I was mentioning this earlier today. You can, well, I'll just say it this way. A lot of people spend a lot of time and energy focusing on the surface of how they look. The crops that are presented in the store are graded on the surface of how they look, right? A lot of farmers, only the number 1s or the A's, maybe the B's, number 2s are accepted for sale, and a lot of the crop that's produced, for some reason, has some aesthetic imperfection. It's not completely uniform, and therefore it's considered to be unfit for sale in the store. Is there anybody here who has no aesthetic imperfections?
Yeah.
You. Okay. 1 out of 30. Right. Right. Do you think it's more important? I mean, come on. What you look like or who you are? Right? And what's the value? The depth of the wholeness of your being, or the surface aesthetic of who you are? It's when we consider it, when we think about the way the market works and what we're, presented as appropriate and inappropriate, this concept that maintaining aesthetic, quote unquote, perfection is the definition of quality is profoundly perverse. And that is the way the market defines quality right now, effectively, is through aesthetic uniformity, and is not looking at nutritional caliber. When we look at these variations that we see, they're 5x, 10x, 20x, it's not 5%. That's a massive variation, and this is, I think of it as this complete bait and switch, this reductionist mechanistic paradigm where we're taught that, this external assessment is the thing, as opposed to the deeper function. But that's why the nose and the tongue are valuable, right? When you take a bite of something and it's not compelling, I like to say this is why our kids don't eat their fruits and vegetables. It's because they're animals and they know better. What you're providing them, they as an animal are spitting out because it's not compelling. You tell them, eat your fruits and vegetables, they're good for you, they're telling you, I haven't heard this story, all I know is my body's saying no. And you berate them, right? And you demean them, and you use all kinds of modes of trickery to cause them to eat the fruits and vegetables. My experience as a farmer is, when I produce high quality carrots, my kids fight over them. Like, I've got my 7-year-old daughter holding my 3-year-old son or 2-year-old son, and she's got a carrot in her hand, and he's ripping it out of her hand because he's an animal. And deep down inside, he knows his body wants that thing, and he's taking it because he wants it. Like, there's a whole deeper level of being here that is part of what's going on. And until we can actually engage this conversation and begin to have context and framing for this topic, I don't think we're really going to be able to move forward. But again, that's part of what we're trying to facilitate through this conversation. And if we can do the research, if we can do the science properly and systemically, and we can build handheld instruments that people can use, I think we can facilitate an amazing awakening of enlightened self-interest for all of us who know that our bodies may not be functioning as well as we'd like them to, and we're really concerned about our children who are not functioning as well as we'd like them to. We can use the money we normally buy food with to choose the best things for them. So this is the grand vision here, is to get to a point where we're shifting from the focus on the surface aesthetic to the deep beingness of the thing, and using the scientific method to do it. Yes.
Two quick ones. A super carrot is super sulfur carrot.
Mhm.
Is it also more likely to be a super other nutrient than an average carrot? One. And two, in Briggs measure of a harvested sample, how does it behave over time if you measure?
So the first question is, how do things connect? If you have extreme levels of sulfur, are you likely to have extreme levels of other things as well? We honestly haven't looked systemically at it. Our first question was really only, what's the scale of nutrient variation? And that's what we're proposing to do now in this next phase, is to look at a whole bunch of nutrients in relationship to each other, from a full global sample, overlaid against microbiome, overlaid against human health response, and properly discern these ratios. And that's why we're trying to accomplish this project. So I don't know. It's a short answer. The piles of data we've collected, millions of data points, dozens of PhDs could be written from the data we've collected. When we show it to people who are proper scientists, have you ever seen a scientist get giddy? Like people that are normally calm and sort of staid and right, not that, but oh my god, can I, would you mind sharing that with me? Yeah, it's really exciting. When you're not saying, you are as a scientist.
My parents
Mhm.
were organic farmers. I thought
Yeah.
your talk was super interesting up till the data, right? Because I think currently you're an activist.
Okay.
You want to become somebody who, from what I'm hearing, who wants to actually influence policy at scale.
I'm not interested in policy, but okay.
No, policy is when people at scale make big difference decisions, right?
Policy is when governments changed laws.
Yeah, exactly.
Yeah.
And at that point, you have real impact.
I am not interested in policy, but keep going.
Okay, well, maybe then you're not interested in real impact. And
Keep going.
personally, I am very interested in people who want to make real impact at scale.
Yes.
How do,
Activists versus actionable results, right? So far you're an activist. I loved your story. I thought your story was super relatable. I thought it was interesting. I could relate to it. I totally relate to what you're saying. Your parents were organic farmers, and we definitely thought we were better than everybody else.
Yep.
I relate to that.
Mhm.
But for you to have real influence, you need to make your results more actionable, right? Currently, you're an activist. At the sample size that you're working at. Let's say, for example, instead of asking for 26 million, right, which is what you asked for here, and you say, okay, I'm going to have 3,000 samples across the U.S. If you have per district, I'm extremely local, and so results happen locally, right? If you have 30 samples in a locality, you can be statistically significant. So it doesn't matter about money. You don't need a ton of money to get statistically significant, robust sample results. But as long as you have people self-reporting, you don't have random, significantly robust results, right? You currently have people self-reporting. Self-reported data by nature is biased. Right? So if you would put a bit of time into getting statistically robust samples, you could have actionable, not activist results, right? And I think I think your story is super powerful. I think you could have real influence, but you need to think about how your results become not just activists.
integrated.
Yeah, but
I
somebody
hear what you're saying.
Yeah.
I look at it, I think it's interesting what you're saying.
Mhm.
But you're not getting to a point where somebody who works in agriculture could step across and say, hey, it's very easy to label somebody as an activist. My mother was continuously labeled as an activist. But the way I'm looking at you, if you don't get your numbers right, You be an activist, and you won't influence policy.
Can I
So you
speak?
And I
made
think
a point.
that's really, really important. For if you really want to make change, I get what you're saying, right? I like that you have these different pieces that you want to handheld and people want to get that. But if you really want to influence change, if you really care about nutrition, which I think you do, right? Then you have to be willing to set yourself against scientific rigor, which you seem to be interested in, right? You don't necessarily need results across the US, across the globe. You need statistically significant results in different regions for where those particular crops matter, right? Most crops in the US are very localized. There's certain crops that do very well in certain regions. Get the statistically relevant sample for that region, do the results, right? Instead of trying to get like everywhere. That sounds a bit boring, but statistics and science is kind of boring. And scientists get excited if you have statistically relevant random samples, right? And what I see so far as an activist, I'd love to hear the scientific version of this, and I'm sure it'll be more boring, right? But it will result in real policy, and real policy is pretty damn exciting. Why? Because it results in widespread change, right? And I get that you have to be an activist sometimes, but the activist part really turns like kind of boring people like me off. And the kind of boring people like me buy the freaking stuff in the supermarket, right? So, like, come to our world and make sure your statistics add up. Like, that's why I was like upset, because like your statistics don't match up. I think you have a great story, but your statistics don't match your story.
All right. The graphs that I showed you, as I said, were the preliminary data. Our preliminary work was a survey. It was self-reported. We were endeavoring to answer a couple of basic questions. What is the scale of variation in the supply chain? And we found enough samples to show that there was a significant variation. That was the first question. Significant variation exists. Are you disagreeing with that conclusion? Well, people self-reported whether they were organic or whether they used cover crops or what the variety of crop was they used, but they didn't self-report the nutrient in the crop. Because the labs we used all had the same protocols, and we were very, we didn't get things published in Nature without having a pretty good scientific method that passed rigor. And so, yes, there was self-reporting on how it was grown, but the nutrient assessments were done in labs by trained lab techs following a formal protocol. So that was the preliminary work. The preliminary work was to assess the scale of variation, to see if we could tease out any causal dynamics in that variation, and to assess whether or not it was possible to build instruments that could measure that at the consumer price point. It was nothing more than that. And I completely agree with you. We did not properly determine where those samples came from if we wanted to do a more complex endeavor. That was phase one. It started in 2017, it concluded in 2021. With beef, we did something much more complex. Again, it was self-reported. There were very specific formal collection processes that all the farmers had to go through. We endeavored to get a broad diversity of bioregions and genetics and things like that. But the treaty we're proposing right now is exactly an attempt to address every single critique you're offering. We're proposing a global treaty which serious credentialed scientists review and approve before we engage it.
Yeah.
This, if you read the process, phase one is experimental design. So we don't do any sampling for any crops until we've worked with the global specialists in potatoes or in wheat or in rice to identify what are the major production areas, what are the primary genetic strains, what are the dominant fertility programs. So we're actually properly assessing the scale of potato production or rice production planet-wide. So yes, we absolutely want to do this to the standard that makes boring people feel like it was done right. if I can say more with a loving tone.
No,
I guess,
agree.
one last,
I love
wait, let me finish.
I think boring people are important.
One last point. There's policy and there's market. I am very, very, very clearly not attempting to affect policy. I am completely cynical about the function of government in legislation and the incentives and agendas that drive government and the ability of that to affect change. Call me an American, but well, I am an American, for better or for worse, sometimes for worse. My understanding is money is a powerful force in today's day and age. And my understanding is that the desire of parents, and dare I say mothers, to do the best they possibly can for their children is one of the most powerful forces in the world. And so what we're attempting to do is engage the scientific method as honestly and categorically as possible to give to mothers the confidence to be able to make decisions for themselves about the betterment of their children without having to trust any governmental agency, any certification framework, any marketing, or any labeling. We're trying to hack straight through all that to use the scientific method and align it with economics for the betterment of many. So there's my response before follow up.
Thank you. Good comeback.
I like a good procedure.
Yeah.
Just a quick one on my end, because Cultiva has been always like a test farm, and I'm a chef slash little gardener. My mom is an agronomic engineer, and she developed all these projects back in Ecuador with multiple cultures from the Andes region, so all the crops at different heights and blah blah blah. So I kind of grew up in that environment, and when I decided to embark myself in my own restaurant, of course I looked into the agricultural side of it, which is controlling what I serve, right? And then we've run experiments, from warm tea, composting, a little bit of agroforestry, and now we're trying something that is everyone else called hydroponics.
Yeah.
So what's your take on it?
My take on hydroponics in relation to the nutrient conversation. That, like everything else, it can be done quite poorly or quite well. There's a massive variation in nutrient levels in hydroponic crops. If you simply put in soluble nutrients and you do everything you can to kill all the life, you're going to get crops with quite low levels of nutrients in them. I've got friends who have used hydroponic systems and been applying foliar sprays of microbes and compost teas onto the leaves of the plants at 30-minute intervals to produce medicinal caliber herbs for the Chinese market in a controlled environment, in a hydroponic system, working with microbes and complex biochemistry. They're producing high, level medicinal caliber plants for a discerning market. So a lot of the tomatoes that are grown in soil, that soil is so dead, it really is just there to hold the plants up. So it seems that regardless of what your structure is, your process is, the level of function of the microbiome is the thing that correlates with the level of complexity of nutritional caliber. And you can optimize that biological vitality in any environment if you're prioritizing it. I don't think that's going to be the most efficient way from a planetary scale to produce food for people. If you just look at the inputs and the logistics required to produce hydroponics versus working on land in nature, I think working on land in nature is going to be able to outcompete hydroponics just because of the input cost. But that doesn't mean you can't do a good job if you're actually trying to optimize the level of function of life in the system.
And so a couple of years ago, I was lucky enough to go and stay in this restaurant in Upstate New York, and his project is amazing, right? and I stayed there for 2 weeks. And as a chef, he was saying, we need to season the soil. Right? Think of that perspective of being a chef. Like, what are we putting in
Yes.
that we want to extract back, right? And that's pure alchemy. And he has this 3-acre farm just surrounds the restaurant, and it's a prototype of what the world could be as you want yours. And the crops that he's putting in, he starts on maybe 50 square meters, a group of carrots. And then the carrot goes all around this 3-acre cycle, and it doesn't come back to that spot after 7 years.
Yeah.
And he has found that the same carrot that is cycling the 3 acres along 7 years of crops, the same seed, it actually changes flavor. Right? And he's tried all the different substrates and flavors, and now he has this company called Rose 7.
Yes, Rose 7 seed.
Correct.
Yeah.
And I tried these varieties, and it was like mind-blowing. The same variety of carrots from different parcels, in the sizing, in the texture, the softness, the bricks, etc. So for me, what you're saying is like we need to season the soil, right, to extract that, and that is super interesting.
I would confirm that this is foundationally what we have been teaching for the last 17 years, is that this soil needs more pepper, this needs more salt, this needs some cumin, this needs some marjoram, this needs some, chili powder. Different soils are imbalanced or deficient in other these key ingredients. Molybdenum or cobalt or sulfur or boron are critical enzyme cofactors for biological system functioning, and different soils are deficient in these things. And if you don't address them, they inhibit overall system function categorically. Sorry, Sue.
Yes, I just wanted to ask, so when we're talking about the minerals, being one factor, but also in that example you just gave us earlier, did he do any in those different rocks? Did he do any microbial assessments? Mineral assessments.
Yeah.
He did.
Yeah.
Did he see differences in those?
Yeah.
Amazing.
It's a full study, because he's
Yeah.
expensive parcels.
I haven't talked to him.
Yeah, that's Jack Algier is the farmer. Dan's the chef.
Yeah.
Jack's the farmer, just so we're clear.
Yeah.
Dan's on the
I
book.
met Jack.
Yeah, it's Jack's farmer.
This whole thing is funded by these multi-billionaires from the States.
Rockefellers?
Correct.
The Rockefellers.
So it's like the pinnacle of
They can
research
afford to
in
do
terms
whatever
of
they
food,
want.
right? They can do whatever they
It's
want.
the land that the Rockefeller, like J.D. Rockefeller,
Yeah.
had his house at.
Yeah.
The Rockefeller. It's his pad.
Yeah.
It's his old barn.
Yeah.
Right? Stone Barns is literally the place. So, so they can do whatever they want. They got a really nice place.
No, but it's cool as a chef to have that ability to practice that and also
And
have,
study that and find out the overlays.
and also have like the methods to have people coming in and try it out.
Yeah.
Because there's one thing, as she's saying, is one thing that you speak about data and you speak about this and that. But if I tell you the story that you're saying from your knowledge with me, in my voice, and then I put 3 dishes in front of you and I make you taste, you're immediately gonna go and buy my story.
Yeah.
Right?
Yeah.
So that's what Dan Barber has.
Yeah.
Like that's the upscale.
Mm.
Anybody else?
No. No, so a few of these friends, they spend thousands of dollars on supplements.
Yeah.
So, I mean, there's a big market, there's a niche market of people who spend a lot of money on nutrition.
Yeah.
So a lot of but it's, I mean,
there's a lot of people.
no, I mean, it's a good amount. So there is money in nutrition.
Yes.
So, would you say if we farm better, we can actually scrap this, and so therefore there must be a lot of money in better farming, like you promote.
This is a really good question. So the problem, one of the biggest problems, is that the only things you need to have really healthy soil come from nature. Nitrogen is in the air, right? Those deficiencies in minerals are in the rock that the continents are made out of, or the seawater that the oceans are made out of. Actually, the things that you really need to improve soil health are natural and freely available in such quantities that nobody can corner the market on them, so nobody has a real incentive to sell them to farmers. Right? The way things work is through businesses, through people selling things to other people, and if there's no real money to be made in selling nature to humans, because it's present everywhere, then it's a significant issue. Like agribusiness makes a lot of money selling stuff to farmers. We're potentially threatening a lot of that bottom line. Pharmaceutical industry or the supplement industry makes a lot of money selling supplements to humans. We can argue because the food we are generally eating is nutritionally insufficient. So yeah, I would suggest that if our food was of higher caliber, we wouldn't need supplements. And so what we're functionally talking about is decreasing GDP. Right, with increased human health, increased soil health, increased overall system function, there's less money to be made. My experience as a farmer is my productivity goes up as my soil health goes up, as my cost of production goes down, so I don't need to charge a premium. I can actually compete on price with the people using chemicals because I can make a living with a lower price point. It's antithetical to the way that the whole profit center dynamic seems to be organized right now, and I would say this is part of why maybe this has not succeeded, is because the only real people who are benefiting are the actual farmers themselves, and the only people who actually have an incentive are the consumers themselves. No industrial player in the middle. Go for it.
So my economic mind doesn't add up because.
Yeah.
If you would sell better vegetables to the people who pay for supplements,
yeah,
you could charge a higher price.
I could.
Yeah, exactly.
Absolutely. Know that they're buying something better.
Yeah.
I totally.
But I mean, yeah, there's about.
But I don't need to.
Why? I mean,
because I have my land, I have my family, I have my car. What do I need? I have my honor.
Yeah.
My honor says that I don't want to be extracting every last bit of cash out of every person I can. If I can make a good livelihood with the privilege that I have, why should I not consider the betterment of all as opposed to optimizing my maximization of money and power? Like, what are we in it for? What's the point of life? Are we here to extract and control and dominate? Or are we here to empower everyone around us? The economic model, this colonized mechanistic paradigm, is at the root of the perversion of so many things based on this assumption that success is me having more. I propose that is not the model of nature. The model of nature is I succeed when everyone around me is happy and empowered, not when I have to have a gate around me because everyone around me is struggling. That is not success. Success is everyone being empowered. And maximizing profit for me is not that. So it is a complete paradigm shift. I suggest the pattern of nature is symbiosis. The pattern of the colonizer is dominance and control. And we have all of these unconscious dynamics established in our culture that we don't even consider. We're trained in them from birth. This is the cultural genocide. This is the generational trauma. This is what we're holding that we need to seriously figure out how to unpack if we want a better future for humanity. This thing goes deep.
Can I speak to this, Dan?
Yes, you may.
For those of you who don't know, I'm Sarah, as Dan referred to before, the Development Director from Bionutrient Food Association. My particular interest is how this can be incorporated into policy and in terms of speaking to the corporate reporting as well around ESG. I wrote Appendix E, which is attached. We didn't give it out to everyone because it's not necessarily of interest to everyone. The specific detailed information on how we propose to put forward the scientific plan, the budget, and also how we see this would be integrated into corporate reporting, or how I see it. Talking about, we could, at the moment, the way the world is, the shift in, the cost of living crisis is very real. people buying supplements aren't necessarily those who are struggling with the cost of living crisis. I get that. But as we are shifting, the GDP is shifting, I believe that we are moving towards more of a well-being economy. And when it comes to nutrient density, it has the power to be an unlock for change in land management practices, but also helping deliver the cost-benefit analysis around public health and the spend on, preventative. So when you look at the wellbeing economy framework that's being proposed by the World Economic Forum, these nutrient density helps to tick those boxes, and it also helps to tick a lot of boxes around capitalism for social, inclusive, the Council for Inclusive Capitalism. So basically, when corporates are reporting their annual profits, the qualitative data that hasn't been captured before about the impact that they're having, the impact that you talk about, actually converting the activism into impact can happen on the reporting sheets, in the company reporting sheets, which are required for listing on stock exchanges around the world. It's coming from the World Bank. It's for those who are financed by the World Bank. It's coming from the higher up financing banks who give our local banks their finance. They want to know the carbon footprint of every client on their books. So if you can say that you can measure the nutrient density of the food that you're producing, and it's higher in quality, and it's going to reduce the cost of public health because it's there and available as higher quality food. Yes, there will be a period where it's going to be able to be, the farmers can charge a premium. But I don't know if you know, in Australia, there's the smashed avo phenomenon. It may have happened elsewhere, but basically, smashed avo was like the hipster food to go out and have at a cafe with your coffee in the morning. Well, at the same time, economists in Australia basically named and shamed the same generation who were buying the smashed avo at cafes were complaining about the fact that they couldn't buy houses. And so it became this big topic. But it also was recognised that because of this phenomenon, a whole heap of farmers went and started planting avocado trees because the avocados were being charged at a premium. Then suddenly we had a huge glut of avocados, and now they're cheap as chips, which is great if you love avocados like I do, but not so great for the farmers. So the way we see it is there will be a period where there will be first movers who are producing food that is higher nutritional quality than other farmers because they were on the inside track. They knew about the work, they knew that it was coming down the pipe, and they made resilient business decisions to be able to not just survive, but thrive through changing economic conditions. But then there will become a time, and this is our hope, and this is where the activism hopefully can change into real impact, that people will be competing to be the best. Farmers will be competing to be the best. It will be a requirement in corporate reporting that, to tick those boxes, and the higher that mark, the more interested investors are in investing in that company. Because the whole point of that extra transparency when it comes to ESG, or environmental social governance as it's called, is to give investors more information around the risks and opportunities in investing in those companies. So I hope that kind of speaks to your comments and gives you a bit more insight into how we see it can be implemented into the system, and at the same time address equality and bringing in more social justice and helping spread the economic reward for farmers and for the people in terms of health. Thank you.
Thank you. Very interesting. I just want to make a general comment to this. The discussion has been very healthy, and I found it very interesting. I'm a scientist. But for a long time, I was excited about my data and then the information generated from the data.
Say what?
The information generated from the data and the publications, until I realized that that was not the end game. Because the end in mind, you have to go beyond the information. The information has to be translated into knowledge, and that knowledge has to lead to some change of behavior, and not of one entity. The change of behavior is what is measured as outcome.
Yes.
Who is changing the behavior for the work that you're doing? And then I realized very quickly that if you can't measure it, you can't improve it.
Yes.
And neither can you effectively regulate it.
Yes.
So as much as we target the policymakers, they are just a very small sample of the people whose behavior we intend to change.
Yes.
Yes.
We need to change several actors' behavior.
Yes.
And if we can, the more we can do, the more impactful we can be.
Mm-hmm.
Because in order to get to impact, the outcome, the change of behavior is critical. So as much as we want to do that, if the change of behavior or the way you look at things from the work that you're doing, then you're on the right track. Thank you.
Thank you very much.
Thank you.
Did you want to say something?
All right, so thank you, Dan. It was very interesting. In the BQI that you didn't explain exactly which nutrients are included in there. Maybe you could elaborate on that a little bit further. And another question is whether you also looked at food fiber in your products, because if you are looking at the soil microbiome, the next step is, and I think some research is already going in that direction, that you're also looking at the microbiome in our gut, which has a big influence on our health.
Massive.
So yeah, I'm interested in whether you looked at food fiber, the amount of fiber in the different products. And the last comment is, which I must agree with the previous commenter, that I mean, the number of samples you took in America are enormous, whereas in the other parts, the other countries, they're significantly less.
Yes.
But
zero in many continents.
yeah, but you did some in the UK, and at one point I saw in Australia. But this afternoon I looked at a documentary which was very interesting because it was about the EU and the fact that they want to change and have agriculture approximately producing 30% of the farmers being organic. Organic between brackets, that can be different systems. But the documentary was highlighting Austria. Austria as a country where already, as we speak, more than 25% of the farming that is done there is organic. And the nice thing was of the presenter that she said, well, the name organic in Austria, it only appeared 15 years ago or 20 years ago when they started with certification. Before, farmers were already organic, but nobody realized
there was no name for it,
that they were doing it organic. And anyway, much of the food system, depending on which part of Austria you are, is still farming the same way.
Yeah.
Also in terms of livestock production, because of course the environment, all the mountains, it's very difficult, still very labor intensive. So if you are doing some sampling in Europe, I think it would be very interesting to go to an area within Europe where traditionally very little things have changed
Yes,
over the years.
yes.
And UK may not be the best example in Europe for that matter. So that's just a tip.
3 or 4 points there. The samples we got from the UK were all from people managing in multi-species pastures. So they were not using, they were the people that were thinking they were doing a better job. Yes.
How many years have they been doing this?
Between 2 and 20. These UK farmers.
Yeah, but I mean,
But I
for
think-
how many years have they been in that system? Did they change it? Were they coming from conventional farming and then they changed? And
Yeah.
for how many years has it been organic or in a new type of system? I mean, that is, in my opinion, important.
Yes.
The reason that I explained the documentary that I was watching is the fact that in Austria, in many parts of Austria, it has been for more than 100 years and nobody has ever changed it.
And Switzerland is another example, right next to Austria,
But
where in the summertime, the cows go up on the mountain pastures that have never had a fertilizer, that have never had a chemical, that have massive diversity. And I think what you're drawing at there is we want to, when we're doing our sampling, we want to identify sources of sampling that are at the edges of the continuum, right? If we think that those perennial traditional systems with polycultures are one edge of the continuum, let's try to find samples from those edges to identify what is, because what we're trying to do here is characterize a 1 to 100 standard. We're not trying to find the median and the mean, we're trying to find the outliers. Because that's really the whole intention of our experimental design, which is actually much different than a lot of scientific work is trying to find. A lot of work is trying to find the middle, we're trying to find the edges.
so that is the
Yeah.
beginning of my tip.
Perfect, I completely agree. And this is exactly why we're trying to engage thoughtful people, is to get suggestions like this, so that we can do as good a job as possible. I will say, and I feel like people, obviously, we've overstayed our time, and I appreciate everyone staying as long as they have. I'll just say one perhaps concluding point that I haven't mentioned yet, but I think it's pertinent. We are hoping to do this as a preliminary definition. We're hoping to establish the first 1 to 100 standard in nutrient levels of food, but we are hoping to inspire governments and the major global NGOs and philanthropies to fund this work at tens of millions or hundreds of millions of dollars scale, because it is really a big project. And $1.25 million per crop is the fewest samples that we think we can get to establish, to have a basic statistically significant definition that has some integrity. Like, this is by no means something that would be a final draft. Our hope is, if we do establish a first definition standard, that somebody who wants to make money can sell meters that are calibrated to, and players in the market begin to make changes, then we'll begin to get some of the governmental agencies applying research dollars, developing research protocols to deepen this work much more. I think it's like just the method of the model of the Human Genome Project, and say the Human Genome Project was a big project that no one university could pull off. And so there was an agreement across a suite of players globally to say, let's work together in a pre-competitive space to figure this thing out together, because none of us has the capacity with our resources to do it systemically. So that's what we're trying to incentivize, perhaps as activists, using the scientific method. We don't want to have what we're doing be the final be all and end all. We want to, see if we can direct action in this direction, because we think there's some patterns here and implications that are meaningful and significant. And if we can use the scientific method and we can begin to align economics, perhaps we can begin to drive that scientific research in this direction.
Great.
All right. Thank you all very much.
Thank you.
I look forward to
Let's all
talking
give Dan a
afterwards.
big round of applause.
And
Thank you. And Sarah.
Thank you, yes, thank you.
Thank you. And for everybody that's stayed back this long and have made those great comments, please do go into the treaty, read the treaty, sign the treaty, put your comments in there, because that's what this process is about. The listening session is to pick up your comments so that Dan's work can actually be optimized based on thoughts and ideas from people that are interested, and the people that are sitting here seem to be interested, so let's do this. Thank you.
Thank you all very much.
And thank you.
Yeah,
Thank you, Ariel, for this fantastic facility and for the lovely food. Very tasty stuff.
Yes, thank you.
My pleasure to have you all here in Casa Su Casa.
Ah, wonderful.
We have one of the biggest agronomists here, and he didn't say a word.
Ah,
This one. He runs probably the biggest farming construction out here.
run,
Shy, like you
run,
said.
run, right?
Very shy.
Come on, Ryan.
No, I you know, that if I have to, I have a deep voice. I don't. No, I'm joking. I'll just say that obviously some of the practices you're mentioning we're using in conventional farming. Yeah. I mean, I would suggest the same as, you know, I think it would be wise to define the goal better. Because it's very clear. I mean, it's a subject that obviously we've been discussing in agriculture for 20, 30 years, you know, the density of nutrients, obviously more in staple crops and food crops, you know, and then the grains and whatever, but even in what we do, which is more on obviously horticulture and other things in Kenya for export mainly. But yeah, actually I agree that if it would go for policies, then if it would come from the market, it would influence the farmers, oblige them basically to go and do these practices better. I mean, you suggest that, I mean, I don't see every person as bad. I don't think the organic farmers are bad, or I don't think the commercial farmers are bad, and I don't think the input suppliers are bad. I mean, I just think the farmers lack knowledge, okay? And it might sound a bit easy, as if there is like a clear prescription to do what you suggest. Obviously, I don't think you that's what you suggest, but obviously it's very, very hard. I mean, the soil biology science is just in its beginning. I mean, I wish we could know. We are testing endlessly, you know, soil biology and basically what are the KPIs to get to what you're suggesting. So if we had, anyway, it's an interesting
That's
subject.
part of the experimental design. Is that we ask the farmers as many questions as possible, so we can determine what are causal factors. So we can begin to tease out what products, what protocols, what processes work in what environmental conditions. Because we want to support all growers globally in a big open data set where these patterns can begin to be discerned. Because we don't know.
Yeah.
Because we don't know.
But I just say it was extremely interesting, and be careful. In 2 hours, try to cover. You know, you started with nutrients and you ended with what's life and why we're here. So I mean, it's very hard to discuss big subjects like this in 2 hours. But well done. Anyway.
Thank you. Thank you.